Okay, this is a video to explain how to use this script. This is a script to estimate exponential smoothing models. The main reference is the book by Rob Hyndman. It is available for free on the internet. Here's the address. And here's the book. If you use the book online, the book is free. You can also buy a print version, obviously. So this is the main reference for this program. Rob Hyndman is probably one of the most famous forecasters in the world. He is the author of this forecaster library, and more recently he has created a new version of that library, which is consistent with the new way of doing R, if you will. It's consistent with this tidyverse universe. So we're gonna load a few libraries at the beginning. Tidyverse. If you don't have this libraries installed, you have to use, before doing this, install packages and then tidyverse. Run it. It will install the library. I already have those libraries installed, so I don't need this. So I'm just gonna run it. Library. You need these two new libraries, the Fable and the Fable library, both written by Rob Hyndman. And now we're gonna start reading the data. We're gonna read two different formats. The first format, the spreadsheet is not gonna have any dates, and we're gonna add the dates to the spreadsheet. Let me show you that beer sales. Let me show you the spreadsheet. There it is. So we have 6 columns. We have 150 observations for each type of beer. And what we want to do is we want to create models, forecasting models for each of the 6 different beers. What I'm thinking here is that when you go in the real world, you have to forecast hundreds of items at the same time, hundreds, thousands of items at the same time, and then you cannot estimate a model that is too careful for each series. You want to automate the process of learning a model. And that's what we're going to do in this video. Okay, so we're going to read the data set using the command read CSV. And notice I'm going to do this 4 commands, and later I'm going to show you how to do it in just one step in a very efficient way using the pipe operator in R. But first I want to show you what each line will do. So I'll do it in a very inefficient way. So first, read the data set. Okay, and then we get 6 variables. They are real numbers. And then let me show it to you. It's just a table is called. It's a data frame with 6 columns of real number data. The second thing we're going to do here is we're going to create the long format version of this data set. Instead of having 6 columns, we're going to have 2 columns. One column that is going to indicate what type of beer we're talking about, and the second column which is going to give us demand for each type of beer. This is a requirement to use the command Fable, which is going to do the forecasting later. So let's do it, and let me show you what's going to happen. Okay, we do it, and see, now we have 2 columns, one for beer. So we're going to have 150 beer A's, 150 beer B's. Let me show it to you. View beer 1. See, the first 150 observations are going to be beer A, 150. And then 151 starts beer B, all the way to observation 300, and then starts beer C, and so on. Okay, so 2 columns, and then what we're gonna do in this line 20 is the command mutate. What it does is create a new variable. So we're gonna create a new variable in this table beer 1. And that new variable is going to be the variable date. See, the way we do it is the following. We create, we use the command year month. So the first observation is going to be January year 2000. and then we just add 150 more, right? We add a 0 at the first one because the first one is going to be January 2000. And we do that 6 times because we have 6 different types of beer. So we're just adding a column, and the column is going to be the date. So let me do it. And let me show it to you. So we have the old 2 columns, and now we have a new date column in the proper format. And finally, we're going to create this new object. This is like a data frame, but the TS means time series. So it's a particular form of table which has incorporated this information about time. So we have to say what's the variable that measures time and what's the variable that gives me the different types of beer. So the variable for time is date. We just created it. And the variable for the different categories is the variable beer. Okay, so let's run it. And it's going to look exactly the same. But now this time this is a TS Fable object. So we're going to be able to manipulate that object with the commands for forecasting. I'm going to remove the object. Here's the object. I'm going to remove it because I'm going to create it in a more efficient way. So let me get rid of it. And this is the way we do these 4 steps into just 1 step. So what we do, first I read the data set, and then this is the pipe operator in R. Then I pass it to the next command. See the next command? Gather. The first argument was a data set. Now we don't have to specify the data set because we're passing whatever command we wrote before, created a data set, and that's the data set we're passing to the command gather. And then we're going to pass it to mutate, and finally we're going to pass it to the command as table. So this is very efficient, but if I had shown you this 4 lines at the beginning, you wouldn't have understood what I was doing. So I'll do it very efficient now. Boop. And let me show it to you again. It's a TS Fable object, exactly the same as we had created before. Okay, so now the part about forecasting. Now, I'm going to create a new object which is going to contain the models fit. I'm going to label this object beer1 fit. And what am I going to do is I'm going to take the data set, the TS Fable that I created before, and I'm going to pass it to this command model, and I'm going to specify, I'm going to name it ETS, and I'm going to specify that I want this exponential smoothing models. I could specify exactly what type of model I want. If I don't do it, and I'm not doing it, then the program is going to search through the different models, and it's going to report the best model for each type of beer. So that's what we want in this case. Remember, in the real world, you're going to have thousands of items, and you want to create those models automatically. So that's what this line is going to do for us. In this case, I only have 6 columns, so it's going to run very quickly. But if you have 1,000 items, 1,000 SKUs, well, it's going to take longer, but it's going to be very efficient. Okay, so let me run it. And it's going to take a while for 6 columns, not too long, I hope. There it is. And let's take a look at the object. And the object is what's called a Fable. It's a table of models. It's a 6x2 for data set for the column A, beer A. The best model is the model ETS MAM. Please go check the book by Hyndman, and that is going to explain what type of model is that. The M means multiplicative, the A means additive. So we have a model. We have the best model for each type of beer, and I didn't have to do anything. So that's the beauty of this simple script, that it's gonna automate the process of estimating different models for different columns. We can report the standard measures of performance. So I'm gonna call it beer one metrics, and I'm gonna pass this object, the object that contains the models, to this function called accuracy, and then I'm gonna let you see what it contains. So here we go. For beer A, we have the model ETS. It was estimated in the training data set, and then we have 8 different metrics. You will recognize the RMSE, the MAPE, etc., etc., etc. The rest of the metrics are explained again in the book by Hyndman. Okay. And why do we want this as to estimate these models? Because we want forecasts. So in this case, how do I create an object that contains forecasts? I take the object that contains the models, and then I ask for a forecast, in this case, for the next year. The unit of time here was a month, so we want 12 months ahead. So the last observation, whatever it was, now we want 12 extra months. This is going to be the forecast. So I'm going to do that. This should run very fast. Okay. And I'll show it to you. And this is a Fable. See? It's a table of forecasts. But there's something new about this forecast. So beer A, model ETS, and then the first date for which I want the forecast, which is July 2012. And what I get is a distribution for that forecast. It's normal with mean 57,306 and variance 3.1 times 10 to the 7. Okay, and then I get the mean here. So typically in forecasting, you get the 95% confidence interval. In this case, you're getting the full distribution. You can extract from this full distribution intervals of any level of confidence you want, and that's what we're gonna do next. Okay. The last line, and perhaps I should show you what it does before running. I'll run it and I'll show it to you, and then I'll explain how I computed it. So we're going to create a table that contains the 95 confidence intervals, and then we're going to export them to a CSV file. I'm not going to explain now. I'm just going to run it, and it runs really quick. Let me show it to you. So we're going to get, for each month, we're going to get 3 columns for each beer. The low limit of the interval, of the 95 confidence interval, the center of the interval, and the upper limit of the interval. 1 for each of the 6 different beers. And then we can export that to Excel or to CSV. That's what I'm going to do here. But I want to show you what I'm doing line by line. So, okay. Remember what beer forecast 1 is. Let me run it again so you can see it. It's just a Fable, a table of models. But what I want is the confidence interval. I'm used to the 95 confidence interval, so I want to export that confidence interval. So this is what we're going to do. And this command hello does precisely that. Okay, let me run this. See, I get the information about the distribution, but then I also get my 95% confidence interval. But it's written in this weird way. If I export to CSV this table, it's going to look weird. So we have to do some work. And the work we're going to do is we're going to unpack that hello. Let me show you how. So let me add this to this. Okay. And let me run it again. So what it's going to do is it's going to unpack that hello. What does that mean? It means this. It's create 2 columns. 1 for the lower limit, 1 for the upper limit. And now this I can export to CSV. Okay, so that's Uh, I don't need everything, so I'm gonna get rid of the information about the distribution. That's what we're gonna do here with the select command. So let me add this. There you go. See, I'm gonna select the beer type, the date, the dot mean, and I'm gonna relabel it mean, and the how do I call it? Quotation marks 95 lowered, and I'm gonna call it low, and quotations, single quotations 95% upward, and I'm gonna call it high. Let me run it. I'm just getting rid of some columns and relabeling some of them. There you go. Beer, date, the center of the interval, the low limit, the high limit. Okay, and notice we are still using the long format, right? So we get 12. Let me show it to you. View. Oh, I cannot do it. We're gonna get 12 rows for beer A. Those are the forecasts for beer A. 12 rows for beer B, for beer C, all the way to beer F. I can't remember what was the last one. So what I'm gonna do here is I'm gonna undo the long format. So I'm gonna pivot wider. So what does pivot wider means? You'll see it in action. Okay. Okay. So let me run it again. And then I get one column for each not for each beer. For each beer I get 3 columns. But the first 6 columns are gonna be the center of the interval. The next 6 columns are gonna be the low interval, the low limit, and the last 6 columns are gonna be the upper limit. And when I do this with this horrible command here, is changing the order in which the columns appear, so that the first 3 columns are gonna refer to beer A, the next 3 for beer B, and so on. I'll let you examine what this horrible line means. Okay, I'll show it to you. Run it, and see now I get the first 3 referred to beer A, the next 3 refer to beer B, and so on. And finally, I'm just going to write a CSV file. Go ahead. And then I have created a CSV file called out.csv. Let me show you an embellished version of that file. The colors, I've added the colors. So I get the date, and then each set of 3 columns refers to one beer. Beer A, beer B, beer C, beer D, E, and F. So these are 6 beers. We could have done one by one, but when you have 10,000 different items, it's not very efficient to do one at a time. And that's the beauty of this particular program. And it's a very elegant way of creating forecasts. Okay. Another very common format is that the data set contains information about the date. So we don't have to create the date, we have to transform it, but we don't have to create it. So here we have the same 6 columns with beer demand, and then we get an extra column, date, uppercase D. And then let me show you how the program is going to differ in that case. It's going to be very similar, and I'll do it in a very inefficient way first, and then I'm going to show you how to do it in one step. Okay, so let me read. I'm going to call it beer 2, and I'm going to show it to you. So see, we get a date column, and then we get the 6 columns for beers. So we're going to do the same. We're gonna create the long format. This is called a wide format. Each beer has a column, and we're gonna create the long format, which is gonna contain information about the date, the beer type, and the demand. Okay. Show it to you. Okay. Date, beer, demand. is a very efficient way of storing information. The next command is just gonna transform the variable date into the format needed by the library Fable. Okay, this year month command comes with Fable. So let's do that. There it is. There's a new variable, new column. It's called dates. And we still have the old one, so we're going to get rid of it. So let's get rid of it. So we're going to select everything except date with upper case D. And this looks like the table we had before with beer 1. And we're going to create the TS evil. And there it is. So this one looks exactly like beer 1. So we can pass it to the Fable command. Let me remove the object because I'm going to recreate it with just one step as I did before. This is very elegant. Okay, I've created a data set. You can see it, beer 2. There it is. And now I'm going to estimate the models, but this time I'm going to show you something else. So I can estimate the ETS models. These are the exponential smoothing models. But I could also estimate ARIMA models. And again, since I'm not specifying which ARIMA model I want to estimate, the program is going to search through the universe of models, and it's going to report the best model according to some criteria. Read the book so you can understand what that criterion is. So let me run it. This is going to take a bit longer because we are estimating ARIMA models, and those are harder to estimate. Okay, I run it, and then I wait a few seconds. It takes longer. Still running. And there it is. Okay, so let's take a look at the object this time. It's going to be slightly different. Beer 2 fit. See, now it contains an extra code. This Mabel, remember a Mabel is a table of models. Before we had the beer type and we had ETS. These were the exponential smoothing models. Well, we added a new column, a column of models with the ARIMA models. So these models you see here, ARIMA 000, 011, 12 with drift. That's the best model for beer A, and so on. Okay, I guess I could take a look at the accuracy of that model. Accuracy, beer 2 fit, and there you go. Now you can compare for beer A, say RMSE. It's slightly better for the ETS model than for ARIMA, but they're in the same neighborhood. Beer 2, 5149, 5205, 780, 878, 2821, 2965, 311, 330, 6041, 6195. So in all cases, the exponential smoothing models perform better than the ARIMA models. So I guess you would choose the ETS models. You could do with this object, with the beer 2 fit, you could do all the things we did with the beer 1 object. For instance, we can we just look at accuracy. You can create forecasts. Let me do it. Let me do this. Let me copy this, and we're gonna put them here. Beer 2 forecast is going to be beer 2 fit, and what the hell, let's change, let's forecast the next 2 years, and let's take a look at the object, beer 2 forecast, and there you have it. You're gonna get one forecast for ETS. You're gonna get one for Arima. I don't know if this is gonna work. Can we pass it to auto plot? Yeah, and then you get a graph for each one of the beers. You get the Arima model, you get the ETS model, and then you get the confidence levels. I guess I could zoom this. Could I? Nope. I could. What could I do with this? Zoom it. Oh yeah, you could zoom it. And there you have it. So those are your next 2 years for the different 6 beers for the 2 types of model. Okay, nice. Okay, I'll stop now.